Hi friends, in this video I am going to discuss the matrices problems of previous exam papers, and please watch my previous video of matrices to know what are the concepts will be given for the exam. First topic is characteristic equation. We need to find out the characteristic equation for a given matrix. Now I am going to discuss about one problem which is given in 2014 AU exam paper. This is the question and it is given for 8 marks. See the question, find the characteristic equation of matrix A and show that A satisfies the equation. Hence evaluate A inverse. Now I am going to find out the characteristic equation first. As I told you in the previous video, there are two methods. First one is A minus lambda I is equals to 0. There are two methods to find out the characteristic equation, and this is the first method. Here we can directly substitute A and I matrices, 3 by 3 I matrices into this, and we can simplify and we'll get the characteristic equation. Otherwise, second method we have, this is the simplified form of the first equation. If we simplify this and we got this equation, characteristic equation directly, that is lambda cube minus s1 lambda square plus s2 lambda minus s3, and these concepts are discussed in previous video. So where s1 is the sum of main diagonal elements. What are the main diagonal elements here? 4 minus 1 minus 1. I'm taking, this is 4 minus 1 minus 1. So some of the main diagonal elements are 2 and S2. This is the sum of minus of main diagonal elements. So what is the minor of the main diagonal element? First see the main diagonal element is 4 and we have to remove this row and column, and we have these rest of the elements, and for that we need to take the determinant. This is the minor of the element of 4. So minus 1, 4, 1, minus 1. So that will give you, see, this is the sum of the main diagonal elements. So we need to take the sum. Next element is minus 1. So you need to remove this row and column, and rest of the elements we need to take the determinant. 4, 3, 3 minus 1. Plus last diagonal element is minus 1. You need to remove row and column, and rest of the elements are 4, 2, 2 minus 1. If you simplify this, you will get S2 as minus 24 and S3 is the determinant of A. That means determinant of 4, 2, 3, 2 minus 1, 4, 3, 1 minus 1. You will get the determinant as 31. So if you just substitute S1, S2, S3 in this first equation, characteristic equation, you will get the characteristic equation as lambda cube minus S1 is 2 here, 2 lambda square, and S2 is minus 24. That is minus 24 into lambda minus S3. 31 is equals to 0. This is the required characteristic equation of the given matrix A. Show that A satisfies the equation. That means, according to the Cayley-Hamilton theorem, we can say that every matrix satisfies its own characteristic equation. So in the same way, they asked us to prove that. So what we need to do is, we need to substitute A in this characteristic equation and write down the equation as A cube minus 2A square minus 24A minus 31I. Here we need to remember that we need to multiply with the identity matrix with the scalar 31 to simplify this matrix equation, and we need to check whether we get 0 or not. For this equation, we need to find out a cube a square, and we need to substitute all the terms. First, we will find out a square, that is the matrix given was 4, 2, 3, 2, minus 1, 4, 3, 1, minus 1. So multiply a with the a. So you will get a square. So just multiply these a into a, and you will get a square as 29, 9, 17, 18, 9 minus 2, 11, 4, 14. And for a cube, a into a square. So a is given, and a square is this one, 29, 9, 17, 18, 9 minus 2, 11, 4 and 14. Again multiply these two matrices and you will get a cube as 185, 66, 106, 84, 25, 92. This is a cube. Now just substitute this a cube term, that means a cube matrix here, and a square matrix this one, and a as we know this one, and I is 3 by 3 identity matrix, and check whether we get the right hand side as 0 or not. So after substituting all these terms we'll get, so I am taking this as second equation, and you'll get a cube as 185, and minus 2 into a square is 29, 9, 17, 11, 4, 14, and 24 minus 24 a, 4, 2, 3, 2 minus 1, 4, 3, 1 minus 1, and minus 31 I, 1, 0, 0, 0, 1, 0, 0, 0, 1. Now simplify first these three matrices and you will get 31, 0, 0, 0, 31, 0, 0, 0, 31. And last fourth matrix is minus. If you multiply inside with the scalar, you will get 31, 0, 0, 0, 31, 0, 0, 0, 31. And if you simplify this term, you will get 0 matrices. 0, 0, 0, 0, 0, 0, 0, 0, which is equals to rth side, right hand side of the second equation. So we can say that A satisfies the equation, and hence we need to calculate again A inverse. How do we calculate A inverse? Is first let's consider this second equation. Second equation is a cube minus 2a square minus 24a minus 31 is equals to 0. And now you multiply this whole equation with A inverse on both the sides. To find out A inverse, this one, to find A inverse. And A inverse into A cube is A square minus 2 into A inverse into A square is minus 24 into A inverse is I minus 31 into A inverse. And here right hand side will get 0. Simplify again. So you will get, if you move this term to right hand side, you will get 31 A inverse is equals to A square minus 2A minus 24 I. And you put all the terms again here for A square and A and I. Substitute them and simplify. You will get 31 into A inverse is equals to minus 3, 5, 11, minus 10, 11, minus 10, 5, 2, minus 8. That implies A inverse is equals to 1 by 31 into minus 3, 5, 11, minus 10, 11, minus 10, 2, minus 8. This is the final answer of A inverse.